Here we have a limit in number 39. X is going to -1. And whenever you are trying to evaluate a limit, if you can do substitution and get an answer, then you're done. And so on this problem, what I'm going to do is I'm going to actually substitute -1 in for x. So I'll have -1 squared, which we know is going to be +1, plus 8. So we're going to have 9 in the numerator. And then on the bottom, we're going to do 2 times -1 plus 5. And we're going to take the square root of that whole thing. So 1 plus 8 is 9. And -2 plus 5 is 3. And we're taking the square root of that. And 9 divided by 3 is 3. So the end result for this limit is the square root of 3. And so that's the value of this limit. And again, when you can do substitution and you get a value, you're done. Sometimes limits don't work out that way. And so we'll take a look at number 73, and we'll see that sometimes there's a little algebra that we have to do to get the limit to work out. So in number 73, you'll notice that x is actually approaching infinity. And these limits are a little tricky to figure out. If I just do substitution, I get a weird result, which we usually call an indeterminate form. When you do 3 times infinity plus 2, that's infinity. And when you do infinity minus 5, that's infinity. And so this is an indeterminate form, but that's good news because that means there's other math that we can do to try and compute this limit. So what I'm going to recommend, and this is, once you do this a couple times, you'll start to see a pattern. But what I'm going to recommend is that we take this expression and we multiply it by a form of 1. In particular, I'm going to multiply the numerator and the denominator by 1 over the highest power of x, which happens to be a linear term, which is just x. So I'm going to multiply by 1 over x on top and bottom, and I'll distribute that. When you distribute that, you get 3x times 1 over x, which is just 3. And then 2 times 1 over x is 2 over x. And when you distribute in the denominator, you get x times 1 over x, which is 1. And -5 times 1 over x, which is minus 5 over x. Now, what you have to remember is that any constant k over infinity, or in other words, when you send x to infinity, this turns into 0. Let me write this a different way here. The limit as x approaches infinity of k over x is 0. Whenever you get a huge denominator over some constant, some real number in the numerator, that tends to 0. And so what I can do in this limit now is I can imagine myself plugging infinity into these two fractions. 2 over infinity turns into 0, and 5 over infinity turns into 0. And the value of this limit is just 3 over 1, which we like to write as 3. And so there's the answer for that limit. Now, what I will tell you is that as you do this trick more and more, you'll start to notice when the degree of the numerator and the denominator are the same. In other words, here we have a first-degree polynomial, 3x plus 2. Here we have a first-degree polynomial, x minus 5. When those degrees are the same, you can take a look at the ratio of the leading coefficients, and that's going to be the limit. So here we have 3 over 1 right here, and sure enough, 3 over 1 was our limit. So as you're working forward with some of these limits as x goes to infinity, if the degree of the polynomial in the numerator is the same as the degree of the polynomial in the denominator, you can sort of bypass my little multiplying by a form of 1 trick, and you can just jump right to the ratio of the coefficients, the ratio of the leading coefficients, and get the answer that way. Keep your questions coming. Keep working hard, and let me know if you need more explanations. Good luck.